Assalamualaikum warahmatullahi wabarakatuh. We are from Group 5 and we will be presenting Chapter 2.1 Powers. Powers is a way to write a multiplication of a number x by itself a given number of times n. For example, if we say 4 to the power of 2 equals to 4 times 4. Or if we say 5 to the power of 3 equals to 5 times 5 times 5. So generally, for any positive whole number n, x to the power of n is equal to x to x times x times x times x for n times. We call x the base, while n is the index of the base or its power. We would either say xn as x raised to the power of n, x to the power of n, or x to the n. For example, t to the power of 5 equals to t times t times t times t times t. It is worth noting when a negative number is raised to an even power, then the answer is positive. For example, negative 2 to the power of 4 equals to negative 2 times negative 2 times negative 2 times negative 2 equals to 16. Moving on to negative powers, we can also have negative numbers as powers. For example, if we say 2 to the power of negative 1 equals to 1 over 2. So more generally, we can say x to the power of negative n equals to 1 over x to the power of n as long as x is not equal to 0. As we can see in the example, 1 over q as 1 over q6 as q to the power of negative 6. We can also simplify multiple terms by collecting terms which are the same. For example, c, d, we collect the terms together separately. We collect the term d, c and d together separately. And it becomes c to the power of 4, d to the power of 2. And then for another example, x, y, z over a, b, we collect all the same term together separately, and it becomes x to the power of 2, y, z to the power of 4 over a, b to the power of 3. Write it as x to the power of 2, y, z to the power of 4, a negative to the power of negative 1, b to the power of negative 3. So we will learn about special cases. Now first, any non-zero number raised to the power of 1 is itself. For example, if we say 3 to the power of 1 equals to 3, or if we say 157 to the power of 1 equals to 157. So we would have x to the power of 1 equals to x. Although we usually do not write bases to the index of 1, we just write the base. So instead of writing x to the power of 1, we will just write x. Next, if any number is raised to the power of 0, it will equal to 1. For example, if 4 to the power of 0 equals to 1, or negative 489 to the power of 0, it will also equal to 1. Therefore, we have x to the power of 0 equals to 1.
Bismillahirrahmanirrahim. Next, we move to rules for power. Okay. In rules for power, we will learn 3 basic rules, which is first is x a times by xb equal to xa plus b. So you can see that there is example. I put an example for you to see. Second rule is xa over xb. How to write? We must write it as xa minus b. Actually, we have learned this in matriculations and tamhidi. Okay, and rules number 3, XA bracket B, we can write it XA times B. We move to the next slide, which is roots. What is root? Root is opposite squaring of a number. Okay, you can see that there is example of a square root and power source of 3, and there is also a fraction example. Okay, then we can see that fractional power roots also can be fractional powers as another, which is often more useful way to write roots. Okay, power source of n, x power source of n equal to x1 over n. Okay, we can write like that. Okay, so I put the example. In the example also have, we can see that also have rules number 2 in rules of powers, which is square root x over x. We can write it as x bracket 1 over 2 minus 1. So that is simple as ABC, right? So hopefully you understand. We move to the next presenter.
Okay, my name is Zunnur Alwani Binti Ahmad Zaki, and I will continue with significant application of power in chemistry problem. So I will talk about application of power in chemistry and what is the significance of it. Okay. So in chemistry, we use power in solubility product constant, which is KSP, and the formula will be like this. Okay, the A plus in KSP formula is cation in aqueous solution, while the B minus in the KSP is anion in aqueous solution, while the small a and b is the coefficient of ion in the dissociation equation. Okay, so KSP is the product of ion concentration in a saturated solution and is raised to the power of its coefficient in the dissociation equation. Then in chemistry we use this equation to know the solubility of a compound. So the higher the KSP is, the more soluble the compound is. So to be more clear, for example, magnesium hydroxide. So the magnesium hydroxide dissociation equation will be like this. Magnesium hydroxide will dissociate into ion magnesium and 2 mole of hydroxide ion. So we can express the KSP as KSP equal to magnesium ion and hydroxide ion that is squared. So in this case, the hydroxide ion will be squared in the solubility product expression. This is because the coefficient of hydroxide ion in the dissociation equation is 2. Okay, so next, in chemistry, we use power in rate of effusion. So, effusion in chemistry is the escape of gaseous molecules through small, usually microscopic hole, such as hole in a balloon, into an evacuated space. So, rate of effusion formula is 1 over square root of molar mass of the gas. So, rate of effusion of a gaseous substance is inversely proportional to the square root of its molar mass, and this is based on Graham's law. And this is considered as power because we must square root the molar mass of the gas in the equation in order to get the rate of effusion. Okay, so in chemistry, effusion usually looks and compares multiple gases to each other. So we will use this formula, which is rate of effusion A divided by rate of effusion B equal to square root of molar mass of gas B divided by molar mass of gas A, which means the ratio of the effusion rates of two gases is the square root of the inverse ratio of their molar masses.
Assalamualaikum. My name is Nurin Adriana Binti Rizman. My matrix number is
TSF1-G5 So today I would like to talk about significant application of power. So as it is function in chemistry, we choose equilibrium constant. Equilibrium constant can be written in terms of concentration and pressure, as we can see in the slide. So this is considered as a power because the general form of the equilibrium constant equation for the reaction is equals to K equals to bracket capital C to the power of small c bracket capital T to the power of D over bracket A capital A to the power of A bracket capital P to the power of P. As example shown in the slide, the reactant is equals to 2CO2 while the product is 2CO2 plus O2. So this means that K equals to bracket CO to the power of 2 times O2 over CO2 to the power of 2. So let's continue. The small letter of C, D, A and B is equal to N in terms of mathematical or known as power. So as we can see here, x to the power of n is equals to x times x times x times x. So that's mean n is equals to how many times the x can be multiplied. So this next, the small letter also function as a coefficient in the example before as highlighted the green color. As we learned before, K is equals to product of reactant. So the next example is kinetic energy. Kinetic energy formula is articulated as kgm squared over s squared. The formula is Ke equals to 1 over 2 mv squared. M equals to mass of the body, V equals to velocity with which body is traveling. This is considered as power because the formula has a power of 2. As we can see before, 1 over 2 mv squared. So this formula also can be switched to another formula. As we can see in the slide, from Ke equals to 1 over 2 mv squared, it becomes V equals to square root 2 Ke over m. So as we can see here, the formula converted from square to square root, which means roots concept is appeared for the kinetic energy. So what I mean by root concept is x to the power of n is equals to square root x. So this is shown that when the square is on the left side, it will change to the square roots on the opposite side. Same goes for other examples. So the example is cube root 27 is equal to 3. It also can be write in different style. What I mean is for example, cube root 27 is equals to 3. So the cube root 27 also can be 27 to the power of 1 over 3. That's all from me. Thank you.
Assalamualaikum and hi. I am Afifah Binti Asif. My metric number 1202528. Okay, so now I will continue the presentation. Okay, so let's do some exercise regarding this topic. Okay, so the question 1 is they ask us to solve the equation, which is 2 the power of 5x plus 2 is equal to 8x. Okay, first thing first, we need to change the 8x to the same base as 2 power of 5x plus 2. We know that 2 power of 3 is equal to 8. So, we right here we change 8 to the 2 power of 3 in the bracket. So, x still there out of the bracket. So, we need to multiply the 2 power of 3 with the x out of the bracket. So it will be 2 power of 3x. Okay, so here left and right side we have same base, so we can equate the power. Okay, so now right here we just have 5x plus 2 equals to 3x. So then we can solve it by drag the 3x to the left side and 2 to the right side. So we will get x equals to -1. Okay, let's move to the next question. Okay, this question they ask us if 17 the power of x is equal to 4913, find the value of 2 power of 2x minus 1. So first thing first, we need to set in our mind that we need to find dx. Okay, so 17 power of x is equal to 4913. So what the value of x that when we 17 power of that x we get 4913. So we know that dx is the how many times we multiply the 17 with the 17. So we get it here 17 power of 3, because 17 multiplied by 17 multiplied by 17, it will get 4913. So the answer of x is 3. But we still not answered the question yet, because this question asks us the value of 2 power of 2x minus 1. So we need to substitute the x value to the x in this question. So from the previous answer, we get x equals to 3. So we just substitute the 3 into the x here, and then we will get 2 power of 5. So we know that 2 power of 5 is equal to the 32.
Okay, question number 3. The following equilibrium process has been studied at 230 degrees Celsius. 2NO plus O2 equilibrium to 2NO2. In one experiment, the concentration of the reacting species at equilibrium are found to be NO equal to 0.0542 m, O2 equals to 0.127 m, and NO2 equals to 15.5 m. Calculate the equilibrium constant Kc of the reaction at this temperature. Okay. To find Kc, we use the formula product over reactant. The product here is NO2 to the power of 2 because we have 2 of NO2 here. Divide with NO to the power of 2 because we have 2 to NO, NO2. To find the unit, first we need to find the unit. To find the unit, we just need to calculate the power of this Kc of this equation. So in the algebraic rule, when it is multiplied together, it will be addition. So 2 plus 1 will be 3, and 2 divided with 3 will be substitution. So it will be 2 minus negative 3, minus 3 will be m negative 1. Okay, to find the value of the Kc, we just need to substitute back all the given information into the formula, and we will get 6.44 exponent 5m negative 1. Okay, question number 4. Calculate the pH of a solution prepared by adding 2 grams of benzoic acid and 2 grams of sodium benzoate in enough water to make 1 liter solution. Given Ka for benzoic acid is 6.3 exponent negative 5. Okay, the formula for pH is pKa plus log concentration of salt over concentration of acid. Okay, first to find the concentration, we need to find the mole. To find the mole, we just use the formula mass
divide with molar mass, and we will get 0.0164 mole for benzoic acid and 0.0139 mole for sodium benzoate. To find the concentration, we just need to divide with the volume of the solution, which is 1 liter, and it will be 0.0164 m and 0.0139 m for sodium benzoate. Okay, then we already get the answer for concentration of salt and acid. Then we need to find the value of the pKa. The value of the pKa is using the formula pKa equals to negative log Ka. Negative log Ka has been given from the equation. It is 6.3 exponent negative 5, so we just substitute back into the formula and we will get 4.2007. Okay, after we get the value we need, and we can just substitute back into the formula of the pH, and we will get the pH for this question is 4.13. It is an acidic. Okay, for question number 5, cyclopropane is converted to propene in the gas phase with a rate constant of 6.7 exponent negative 4 at 500 degrees Celsius. How long will it take for the concentration of cyclopropane to decrease from 0.25 m to 0.15 m? Okay, given from the question. Okay, then we need to use the formula ln A equals to negative KT plus ln A inertial. We already know the value of both ln, so we just substitute back into the equation and we will get 762.42 seconds. That's all.